Okay, hi everybody. So we're going to take a quick look here in this video at some common factoring. So here we go. We've got x to the negative 3 plus 5 multiplied by x to the negative 2 plus x to the negative 1. So what we want to do here is we want to find that piece that's common to all three of these terms, particularly that factor with the smallest exponent. So I'm going to take a look at the x's here. That's what I'm seeing here. So I've got an x here, an x there, an x there. And I got to be really careful about this. The smallest exponent here is going to be x to the negative 3. That's what I'm looking for. So that's what I'm going to factor out. And when I do that, okay, x to the negative 3 divided by x to the negative 3 is simply going to be 1. And then I'm going to get 5x to the negative 2 divided by, because that's what I'm doing, when I'm factoring it out, I'm dividing. 5x to the negative 2 divided by x to the negative 3 is actually going to end up being 5x. And I know that this tends to be something that people will look at and go, wait a minute, what? How did that happen? Well, here we go. So 5x to the negative 2 divided by x to the negative 3. Remember that when I divide here, I am subtracting exponents. So it becomes x to the negative 2 minus negative 3. It's that minus negative 3 that becomes the problem here. That is 5x to the negative 2 plus 3, which is simply 5x to the 1. Just like in our last term, when I've got x to the negative 1 and I'm going to divide out x to the negative 3, that is going to become x squared. And again, let's take a quick look at that. That's x to the negative 1 divided by x to the negative 3. That is going to be x to the negative 1 minus negative 3. So again, I'm adding. This becomes x to the negative 1 plus 3, which is x squared. So that's where these exponents are coming from. Now, I'm going to rewrite this in the order x squared plus 5x plus 1, basically so that I've got a decreasing values in terms of the degree of each term. And now I want to check to see if I can go any further with that. Can I factor that any further? Well, it doesn't really look like it. Okay, there's no factors of 1 that I can multiply, that I can add together. They're going to create 5 here. But what I might do, just to double check here, is I might check the discriminant, which is b squared minus 4ac. And I'm looking for a perfect square here. So b is 5, so 5 squared minus 4 times the a value is 1. The c value is 1, so it's going to be 25 minus 4, and I get 21, which is not a perfect square. And so that means that's the answer that I'm shooting for right there.